All right, well, it's just about 7 o'clock, so we'll get started. Hi, everybody, and welcome to the Harris Center's How to Be a Stargazer with Dave McDonald. This is really exciting. Miles just said we have over 200 people signed up, and I was joking that we only get those numbers when we have a live wild animal. So this is exciting that stars brought it out, and it's no wonder we're stuck at home a lot, and what better way to be able to entertain yourself than to be able to go out and look up at the sky, find the stories that are happening up there, and be kind of mesmerized by the beauty and vastness of the night sky. Before we get started on tonight's program, I want to just let everybody know a little bit about the Harris Center, since I see that there's lots of people here who aren't usually at Harris Center programs. So I'm Susie Spickle, and I'm the Community Programs Director at the Harris Center. And the Harris Center is a small land trust in southwestern New Hampshire and Hancock. We've protected over 24,000 acres over the past 50 years. And not only have we protected land for people to be out on and wildlife to roam on and for people to explore, we also have a really developed education program. We go into the public schools in the Monadnock region, and we teach over 5,000 students every year from kindergarten through 12th grade. We work with college students at Keene State College and Franklin Pierce, graduate students at Antioch University, and we also do tons of public programs, just like what you're hearing tonight. About so many people, Dave McDonald, and Dave McDonald has been passionate and interested in the night sky and astronomy since middle school ages, since he was back in middle school, and he's sort of made a career out of it. And I've been fortunate enough, when I was at the McAuliffe-Shepard Discovery Center a while ago, I got to hear him do the planetarium talk, and that was really exciting. I became a big fan. I heard him on public radio talking about the night sky, and he's just told me that he has a TV show, which is so cool. He's going to send the links to the TV show and radio show that he does, and we'll send that out to the whole list. So you can catch more about Dave by clicking those links that we'll send to you probably on Tuesday when we get back in the office. So he also teaches astronomy across the state in universities and colleges and graduate programs, New Hampshire Technical Institute, Plymouth State, the Granite College, and he teaches at Belmont High School as well. And I got to just say that I saw Dave talk, it's got to be about 15 years ago, maybe. Is that about right? It was when my older kids were little, and his program, I'll always remember it. He's a wonderful educator who is able to make something as complex as astronomy seem really exciting, understandable, and funny. Has a great sense of humor. So enough of me, and I'm going to turn it over to Dave. Dave, take it away.
Well, Susie, thank you very much for those very kind words. I can't wait to see the recording after all that. I can't wait to see how it comes. But so as Miles mentioned, also feel free to, to type down some questions along the way, because the important thing to me as an educator and as a lover of astronomy in the night sky is that when the program's over, you learn 2 or 3 things that you didn't know before that you can go out and find and look at in the night sky yourself and say, wow, that's just what Dave said. So feel free to ask questions. I'm happy to repeat myself and happy to answer questions, explore new things that I even wasn't planning on talking about tonight. So as I tell my audience at the McAuliffe-Shepard Discovery Center Planetarium, when I'm doing a Tonight Sky show, I'm like the DJ of the sky. I take requests. But I have no shortage of things to say, as my students at Belmont High School will tell you. Mr. McDonald has no shortage of things to say. Okay, so with that, I'll begin. And I'm going to, as I talk about the night sky and the constellations and the stars, I will also give you some information about the stars and about different things to look out for, and maybe little pieces of knowledge. And though this is, It's not a class. We're not going to have a quiz or a test tomorrow. But if you want to have a, a note piece of paper, pen or pencil handy to jot some things down, because I think you will find my presentation information rich. But and you may just want to sit back and just enjoy and, watch the recording later and jot down some notes later. So whatever is comfortable for you. The important thing, again, for me is for you to enjoy it and for you to learn 2 or 3 things that you didn't know before. Shot, yes? Okay. So this is the night sky facing south. And so you can see the little red S, and I like this program. This program is called Stellarium, is what I'm using to present to you tonight. And it kind of mimics the planetarium in a lot of ways. And one way is the big red S that would be at the front of the theater. There's the red S at the bottom of the screen, meaning we are facing south. And the time that we're looking at right now is just to explain it so you can watch yourself, because the program is in real time in the standpoint of time is ticking. The stars are actually in motion right now and they're moving. And so I thought that we would start at a little after 8 o'clock. So down the bottom, the time is down there in 24-hour time. So 20 hours subtract 12 is 8. So 8:42 is the official time, but I'm just rounding it to like 8:30. 8:30 hopefully is a reasonable time for you folks to get out this time of year. It's after supper, it's after the news, it's before you, well, I'm not really sure when you go to bed, but it's maybe before you go to bed. It's certainly after the sun has set and the sky is nice and dark. So I'm going to present the sky as it appears about 8:30. So I'm actually going to back up just a little bit time-wise till I get to 8:30. So we're going to start at 8:30. And as I said, the time's going to move forward. So I might go to maybe 8:20 or so, and then time is going to be marching on. So is that a good time? Is 8:30 acceptable to everybody? Or does somebody say, oh, it's got to be 6 o'clock. I go to bed at 7. Is 8:30 okay for everybody? Nobody's disagreeing? Okay, so this is 8:30. And the time is, today or tonight, but the sky stays relatively the same from night to night. And I say relatively because it does change. It changes by 4 minutes every night. So when 2 weeks go by, 4 minutes times 14, but technically 15 is an hour. Okay. So what we're looking at now at 8 o'clock, we'll say 8:30 at night, right? So what we're seeing now at 8:30 at night, we're going to be able to see in 2 weeks at 7:30 at night.
Over here.
So the sky does change in that way. So let's take a look at what we're looking at. So you probably can recognize perhaps what I'm circling here. This is the constellation of Orion. Orion is known as the hunter. And Orion is the place in the winter sky that we will start from and find some other things. We use a process called star hopping. And I've used that phrase before I worked at the Discovery Center and the planetarium, but you may know that our website at the McAuliffe-Shepard Discovery Center is starhop.com, starhop.com. And so that came from the technique that is often used to help people find their way around the night sky, is star hopping. You start from someplace and you hop around the sky. So our starting place is going to be the constellation of Orion, which I don't think you can miss. It's in the southern sky. 8:30 you go out, you look south, and just a little bit maybe to your left, a little bit towards the east, and you can't miss Orion here. So let's just talk about Orion itself, and then I will talk about some of the other constellations and stars that we can hop to from Orion. So uh, you can see a couple of stars are labeled here. So as we look at Orion, and just real quickly, and I'm gonna change it in just a minute. Let me just see um, there. So there's some artwork. Okay, so Orion is the hunter, and he's got a sword in his sheath, and then he has a club over his head. It looks like he hunted and caught something that's draped over his left arm and such. So Orion is known as the hunter. Another way that you will often see Orion depicted is in his, which I personally prefer, is seeing a shield, in his left hand, a sword over his head in his right hand, and a shield held by his left hand, defending himself against Taurus the bull. And we'll talk about Taurus in a little bit. Um, okay, so that's just a little artwork of Orion the hunter. So the upper left star, as we look at Orion, is named Beetlejuice. And Beetlejuice is not like the movie, and you don't have to say it however many times you're supposed to say it. Beetlejuice is a bright red giant star, and you can see it's colored a little bit. You probably can see a little coloration on your computer screen, and it's a red giant, which basically means it's in its later years of its life, and it's going to go supernova at some point in time. We don't know when. We never know when those events are going to happen exactly. And an interesting thing is it could have already happened. So Betelgeuse is around 550 light years away. So when I use the term light year, a light year is a measure of distance. Light travels 186,000 miles every second. That's like going around the equator of Earth 7 times in 1 second. The moon is on average around 240,000 miles away, and it takes light 1.25 seconds to get to the moon. So if you had a laser pointer and you went out at night when the moon's out and you point your laser pointer at the moon and push the button and the beam leaves your laser pointer, it will land on the moon 1.25 seconds later. That's pretty quick, 1.25 seconds to go 240,000 miles on average. The sun that we look at, and again, don't look directly at the sun ever, but the sun is 93 million miles away, which is about 8.5 minutes. So when you look at the sun, and again, don't look directly at the sun, number 14 welder's glass is what's appropriate to look. If you want to look at the sun, you can get eclipse glasses, certified eclipse glasses, and number 14 welder's glass also works. But the light we see from the sun, we're not looking at the sun the way it looks right now. We're looking at the sun the way it looked 8.5 minutes ago. So in other words, and this isn't going to happen anytime soon, but if the sun were to go out, the sun is gone, it went out, we wouldn't know that it went out for 8.5 minutes. So the star Betelgeuse here, being over 500 light years away, means when we look at it, we're looking at the light that left Betelgeuse over 500 years ago. So it's possible, and I'm not saying it's happened, and there's no way for us to tell, It's possible that Betelgeuse has already gone supernova and has already burned out, and it's not even there anymore. And maybe that happened a couple hundred years ago, and we won't know about it for another 300 plus years. So that's kind of how the distance scale relative to light years works.
Hey, Dave,
So,
there's a couple of questions. Can I ask a few
sure,
questions from the audience? Great.
absolutely.
Okay, well, one of the questions from William Vincent, he'd like to know, with lesser light pollution, do constellations look more similar to their namesakes? So I guess it's a question about how light pollution impacts what we see.
I'm going to say no. I don't think light pollution, I mean, light pollution definitely affects what we see. But if I'm hearing your question specifically, does it affect how we see constellations in relationship to what they're supposed to be? Well, let me say a couple things. So my answer is yes and no, I guess. So most of the more popular constellations have brighter stars. And of course, we have to know about how much light pollution are you talking about. For example, if you go out on a dark uh, site place in New Hampshire, like up to Hart's location, right on 302 through Prophet Notch there, if you go to a really dark site and you look up, um, not that you're going to count them, but you can probably see 1,500 stars. On a typical, not the darkest place, a dark place, but not like that dark, like maybe in Hillsborough, right? Maybe in Washington, New Hampshire, someplace where it's relatively dark, but there are still, some fringe lights from Manchester or wherever. Maybe you see 1,000 stars. Okay. Well, let me tell you something. I'm told if you were in New York City, you can see 15 stars. Can you believe that? In New York City, you can see 15 stars. It's that bright. There's that much, light pollution and probably a little smog pollution too. Uh, but as far as it affecting what you see, well, I guess the answer is the degree of light pollution makes a difference. Some of the constellations are really dim and have really dim stars. So if you had a star map, a star chart, and you were looking for a dim constellation, well, the answer, I guess, is definitely yes, because you wouldn't even find the constellation. But another part of your question, let me get to that. So let me show you a constellation that very few people even know exists, okay? So if you look over here, excuse me, as we look at Orion, to the left of Orion, as we look at him, you see a unicorn, and that's a constellation called Monoceros. Who knew there was a unicorn constellation? Well, there is. It's called Monoceros. But it is also made up of very faint stars, and that's why they're just little dots, little specks of light here. And I'm sure if you're anywhere near Manchester, for example, Nashua, Laconia, Concord, uh, you're not even going to see these stars. So Monoceros is not going to be a target for you. The other part of your question was looking like what they're supposed to look like. And that part of the question, I have to say, is like, well, the ancients in Babylonia, because Babylonia, Mesopotamia, Babylon, Baghdad in particular, was a cradle of astronomy. And they had to watch television by candlelight. So they had a lot of free time on their hands. And so I assume, of course, I wasn't there. You go out at night just like we would do, like as you did as a kid, and maybe you still do with your kids, or maybe you just do it like if you're out on a picnic. You look at the clouds in the sky, right? When there's a lot of nice, puffy, white cumulus clouds, you just look up and, oh, I see an elephant. Oh, I see a turtle. I see a dolphin. I see a monkey on the back of a giraffe. You see these cloud things. Well, that's what the ancients did with the stars. and they had some pretty good imaginations. Like, I think that as I circle Orion here as a hunter, you can picture there's stars here that look like the sword going over his head. And if you look at this here, and this is why I like the shield artwork better than, the dead animal over the arm artwork. But you see the stars I'm tracing here, you could picture that being a shield. You can, I think, definitely see these three stars making up a belt of a person or a hunter in this case. And then you see these stars underneath the belt being the sheath for a sword. So some constellations, we can look at them and say, oh, yeah, okay, I can see that. And then again, I would dare say most other constellations we look at, how did they get that? So I know that was a lot of words. Did that help answer your question, William?
Yes, thank you.
Great. Dave, maybe I'll hang on to the questions to the end so that we can hear all about the night sky. And if you could save like 15 minutes at the end, then we could ask the questions. That way we can learn all about the
Okay,
sky.
well, tell you what, I will talk about what I'm talking about on this screen and then pause for questions about this, because then I have a totally different screen I want to go to. So
Perfect.
I'll talk about this and then we can ask questions about what I'm showing you now.
Super.
Okay, so good. So then the bottom right, which would be Orion's left foot, as we look at it, it's bottom right, but it's Orion's left foot, is a star named Rigel. And Rigel is bluish, a blue-white star. And one thing that I hope that you will learn and hopefully you will get to see is that stars have colors to them. So I'm just going to pull down here so Aldebaran shows up. And beetlejuice is definitely reddish. It's not like bright beaming red like a traffic light, but you need to give yourself time for your eyes to adapt. So stepping out your kitchen door, standing in your driveway with your head cocked back, uh, you know, for 5 minutes is not going to do anything. You may say, oh, yeah, there's some stars out. You've got to give yourself at least 15 minutes just for your eyes to adapt. And because just a little bit of physiology, your eye, the retina, the back of your eye, right, is made up of what are called rods and cones. The cones are at the center part or the fovea of your eye, and they are the color receptors. And then around the outer side, and there's a whole lot more, are what are called the rods, and those are black and white receptors, much more sensitive to light, but black and white. But you need to give your rods and your cones time to adapt and adjust to the darkness. And then you're going to see some stars pop in with some color that you didn't see before. And you will be able to see, trust me, on a dark, clear night, when you've given your eyes 15 minutes to adjust, you turn, any floodlights around, you call your neighbor and say, hey, Mildred, turn your floodlight off. You want it dark. And you'll be able to see Betelgeuse is definitely reddish. Rigel is definitely bluish white. You'll see it. And Aldebaran, which is the eye of the bull, we'll talk about in a moment, is orangish. Stars have color. And that would be one thing I hope you would get from tonight, is to notice, oh yeah, stars do have color. Well, what does the color mean? Contrary to intuition or what we're taught with the air conditioning heater lever or dial in our car, right? We're taught that, oh, you want hot, turn it to the red. You want air conditioning, turn it to the blue. In a hotel room, when you go to a hotel room, the hot water is marked with a red dot and the cold water is marked with a blue dot. That's backwards, folks. Red means cool when you're talking about stars. Blue means hot when you're talking about stars, right? You remember when you were in school, what color flame did you want your Bunsen burner to be? You wanted a blue flame for your Bunsen burner because that's the hottest. If you had a if you were a blacksmith and you had a horseshoe that you were molding, you put it in the fire and you beef it up really hot. The first thing, it starts to glow red. And then if you make it hotter and hotter, it starts to glow orange. And you make that horseshoe hotter and hotter, it starts to glow yellow. Hotter and hotter, it starts to glow white. You've heard of white hot. And then if you keep pumping the air into the fire, eventually you could get that horseshoe. You'd really need a hot fire to glow blue hot. So red is the coolest color, blue is the hottest color. So red, orange, yellow, white, and then blue. That's the order from coolest to hottest. So when you're looking at stars, you're getting an idea of how hot they are. So Aldebaran, the eye of the bull, is orange, and so it's a little bit hotter than Betelgeuse, much cooler than Rigel. Rigel is really, really hot. The three stars that make up Orion's belt, Alnitak, Alnilam, and Mintaka, they're all white stars, and they're really hot stars, different distances away. So there's Orion. So now let's do a little bit of star hopping. And I'm going to show you some constellations in what we call the winter hexagon. And then we will take a little bit of a question and answer about the constellations and the stars I'm going to show you. Okay. So starting our star hopping with um, Orion, we're going to make a hexagon. It's not going to be a perfect geometric, all the angles are equal hexagon, but it will have 6 sides. And Betelgeuse is going to be the middle or the center-ish, not exactly, but somewhere in the middle of our hexagon. So we're going to start with Rigel, which I already mentioned to you. The bottom right star, as we look at Orion, Rigel is blue. It's a hot star. It's a magnitude 0. So here's another concept. When you're looking at stars, they have different brightnesses. Some are brighter, some are dimmer. There are numbers that we attach to the brightness of a star, and they're called magnitude, specifically apparent magnitude. And both Betelgeuse and Rigel are magnitude 0. And a magnitude 0 is a very bright star. We only have, I think, 2 stars in our sky that have negative magnitudes. So the lower the number or the more negative the number, the brighter the object. The higher the number, the dimmer the object. And the limit of human visibility for most people is a magnitude 6. So, and I'm not sure I have ever seen a magnitude 6 star. I think out in Arizona you can do that. Okay, so Rigel, part of Orion, part of our winter hexagon. Okay, then we're going to go up to this star here, Aldebaran, as part of our winter hexagon here. And if you take the 3 stars of Orion's belt and you star hop upwards, you come to Aldebaran and you can't miss it. 3 stars of Orion, we move up, we come to Aldebaran. You'll notice it has an orangish tint to it. Remember, you've got to get your eyes 15 minutes or so adapted to the dark to be able to discern the color well. And look at this. See this V shape here? That's like the face of the bull. So that's kind of neat. And then if you were to look up here, you see 2 stars representing the horns of the bull. So this is one of the constellations that you might say looks something like what it's supposed to. You have the face of a bull. This is one of the eyes. You have the horns up here. And then off the back of the bull, kind of on the shoulders, we've got some flies. Well, this is a star cluster called the Pleiades. And some people call it the 7 sisters. Well, there's actually more than 7 stars there if you had binoculars. And if you have binoculars, I would encourage you to buy some if you don't get, spend $100, $150 for, don't get cheap $50 binoculars. Spend $100, $150. Get some decent binoculars. I would say like a 50 millimeter by 7 or by 8. I would not get anything more powerful than 8 power binoculars. I mean, you can buy 9, 10, you can buy 25 power binoculars. Oh, yeah, the more power, the better. No, 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 it's not true. 7 or 8 power tops. Because what happens with binoculars when you're looking, not only is the object magnified, but the motion is. The higher powered binoculars are if you want to buy a tripod, you want to buy a stand that holds the binoculars steady, and you just kind of look through the binoculars like you look through a telescope. So 7 by 50s is good, but good quality, not toy store binoculars. And if you look at the Pleiades with binoculars, you'll see 20, 30, 40 stars there, and they're beautiful. With the unaided eye, though it's called the Seven Sisters, most people only see 6, can count 6. Again, out west in Arizona, Utah, you get to see all 7, and some claim to see 10. But the Pleiades is a long known ancient star cluster. Appears in old literature. It appears in the Bible, in the Old Testament, and the Bible talks about Orion and the Pleiades, as a matter of fact. Okay, so just taking a quick look at the artwork here. Again, there's the eye of the bull, the horns, and the flies, I call them to start with, on the back of Taurus, the bull. But the interesting thing is the constellation is Taurus. The word Pleiades in Japanese is Subaru. So remember the car? If you look at the car, the Subaru car, it has 6 stars as its insignia for Subaru. That's the Pleiades. So now you know some Japanese. Subaru means Pleiades. But I find it interesting that we have a Subaru riding on the back of a Taurus. I'm sure there were a lot of chuckles there that I just didn't hear. Okay, we're going to continue our tour here of our winter hexagon. So we have Orion, we came up to Aldebaran, and then if you go above Orion, straight up in the sky, you come to a bright star, Capella. Capella is also a magnitude 0 star, which is very bright. Aldebaran is a magnitude 1 star. Okay, so Aldebaran is not as bright as Betelgeuse or Capella. It's orange. Each magnitude is about 2.5 times as bright or dimmer. Okay, so 2.5 times per magnitude. So Capella is about 2.5 times brighter than Aldebaran is. And Capella is a yellow star. So right here, we've got 3 colors: Betelgeuse, red; Aldebaran, orange; Capella, yellow. Capella, around 8:30 at night, rules the overhead sky. You want to find Capella real quick, like you can star hop. Okay, here's Orion. If I look above Orion, I'm going to come to Capella. You know what? If you want to find Capella real quick at 8:30 at night, you just go, and it's going to be right overhead. The bright star right overhead, or close to overhead, is Capella. Capella is in the constellation of Auriga, the charioteer, and you never know how they're going to draw it. How this charioteer is drawn, I'm not sure, but hanging off of Capella is this like little triangle, which you can see in the sky. And it kind of, to me, it makes like a C. And that's how I remember Auriga, Capella, the bright star Capella, very bright, yellowish, kind of makes a C here with this little triangle hanging off of Capella. So a yellow star, it's pretty hot. It's like in the middle temperature-wise. Okay, so in our tour here, we've gone from Rigel to Aldebaran, Capella overhead, and now we're going to kind of go over the other side from overhead, and we're going to come to these two stars, and these two stars are Castor and Pollux. I'm not sure why they didn't put the name Castor on here, but Castor and Pollux, they're the twins, right? Gemini, the twins. And this is where you find the twins. If you remember the names of the twins, Castor and Pollux, the thing that might be hard is, well, which one's Castor and which one's Pollux? The way I remember it is Castor begins with a C. Capella begins with a C. So Castor is closer to Capella than Pollux is. So Castor and Pollux are the two stars, and they make the twins. And the two stars, Castor and Pollux of the twins, represent typically the head or the eyes or the necks of the twins, represented like this in this artist's rendition, the two stars being the heads of the twins, Castor and Pollux. Okay, as we make our way around, and I'm going to, in a minute, I'll pull back and kind of show you the hexagon all together, but we're kind of, it's kind of like a circle, but it's a hexagon because it's got 6 vertices. Although Pollux is the official vertice, Castor is right there, but Castor technically is not part of the winter hexagon, but we have to mention it. It's the other twin. And as we keep coming around, we come to a star called Procyon. And Procyon is a nice bright star, about a magnitude 0.5, not quite as bright as Betelgeuse, but brighter, a little bit brighter than Aldebaran. And it's kind of a whitish star. As you look at it, you'll notice it's kind of whitish. And Procyon is the little dog biggest star, the main star in Canis Minor, the little dog. And so there's the little dog on the back of Monoceros, on the back of the unicorn. Again, the unicorn, very dim star, so I really am not going to spend any time with it. If you have a star chart and a really dark site, it could be a fun challenge to see if you can find some of the stars in Monoceros, but it's not something we're going to focus on tonight. Just be aware that the little dog is standing on the back of a unicorn. Okay, then as we complete our trip around, we come to the star Sirius, and Sirius is the brightest star in the night sky. In the night sky, obviously, our sun is a star in the daytime sky. Sirius is a negative 1.44 magnitude. It's the brightest star in either hemisphere, either north or southern hemisphere, negative 1.44 magnitude. And that is the brightest star in the constellation of Canis Major, the big dog. And so Sirius usually represents the head, an eye, or the neck of the big dog. And no matter what planetarium type software you use, different artists create the images, and so you get different looking things. So there is Sirius. So now I'm going to just pull back a little bit, and so we can kind of see the hexagon all together. So again, we're facing south, right? And the time has advanced. It's almost, well, it's 10 minutes of 9 now on this sky. But again, 8 o'clock, 9 o'clock, they really look very, very similar. So you can see here's Orion. We said Betelgeuse was center-ish of this hexagon. We start with Rigel, and then we go, Rigel is 1 vertice, and we go to Aldebaran, number 2, Capella, number 3, Pollux, number 4, Procyon, number 5, and Sirius, number 6. Hexagon, 6 sides. And those are the 6 sides of the winter hexagon with their constellations, with Betelgeuse kind of in the middle. Okay, so that's a bunch of things that you can go out and find in the winter sky this week. I think Wednesday is looking like the best night. I have one other thing I want to show you on this screen, and then I'll take questions. If you look over here to the right, you see Mars and Uranus. And Mars, you can't miss it. It's very bright. It's in the realm of a magnitude 0. It is definitely reddish in color. So it's kind of in a little bit of an arc. From Orion, you've got Betelgeuse, Aldebaran, and keep on going, kind of in an arc. You can't miss Mars. It's just so bright and so reddish. And Uranus is hanging out right next to Mars, just underneath it, but you will need binoculars to see Uranus. Uranus is technically a 5.8 magnitude, so technically it should be visible to the unaided eye. But like I said, you need ideal, dark, dry, uh, ideal conditions to be able to see a magnitude 5.8, because 6 is the limit of human visibility for most people, and we will see how that works. Binoculars, you'll have Mars and Uranus in the same binocular view. So you can say, I saw Uranus. Very few people have seen it. It was discovered in the 1700s by Sir William Herschel, and that immediately doubled the size of our solar system because the ancients knew Mercury, Venus, Earth, Mars, Jupiter, and Saturn out to what we call about 10 astronomical units, or 10 times the distance of Earth from the sun. And when we found Uranus, now we're out to 20 astronomical units, and we literally doubled the size of our solar system when we found Uranus. So you can't miss it. Okay, I'll pause for questions on this part of the sky.
Wow, Dave, that was great. Thank you. What a tour. I can't wait for the next clear night, which I guess will have to be Wednesday. So there are a bunch of questions. One, somebody would like to know what your favorite star or constellation is and why.
Oh, that's an interesting question.
Yeah.
Um, I could say I like them all because I do kind of I do kind of like them all. Um, I would say my favorite constellation, and I'll just say in the winter, okay, because it's a whole different bunch of stars in the summer. In the winter, I like Taurus the Bull. I find Taurus being to be just very interesting. You have the face of the bull, Aldebaran, the bright eye of the bull, orange star. You have the horns of the bull, and the Pleiades are just so fascinating with binoculars. They just stand out. And so, okay, I'll stop there.
It's
Taurus
good.
the bull.
Sounds good. Thank you. So somebody has a stellarium of their own, and they're wondering about the artwork for the constellation. Is it included, or do they need to get it somewhere else?
No, it should be the letter R. When you push R, art work, right? So push the letter R, and it's like here I'm pushing R, and the artwork appears, and I push R again, and it goes away.
Cool. Okay. And then what's the magnitude of the sun?
That's an excellent question. Negative 26.
Wow. Okay. Thank you. And
And if I could, just while we're on that, the moon is about a negative 12.
wow. Okay. That's good.
So
How many different color stars are known? Did you name them all? Does it go from red to blue, or are there ones in between?
well, there's always, just like the rainbow, there's always, the gradient, kind of a little in between, but it's red, orange, yellow, white, and blue.
Okay.
Some have added a color, electric blue, which I guess is some kind of a deeper, blue that's really, really hot. But those are, and there's a saying in uh, astronomy, to get a little more technical. Oh, be a fine girl, kiss me. So
Whoa.
they're the O stars are the blue stars, B stars, which are the blue white stars, A stars are white, uh, F are the yellow stars. G are the G are the yellow stars, like our sun. F are the yellow white stars. Uh, be a fine girl. And then the K stars are orange, and then the M stars are red. So it's a definite progression of colors that are pretty definite. And if you were to look up another time, I'm not going to talk about it here, but what's called the HR diagram or the Hertzsprung-Russell diagram, the x-axis is all about temperature and color, and those are the colors.
Wow, thank you. All right, I find this question really interesting. So the constellations and the pictures that you showed and sort of the stories around them, that's sort of from our Western mythology. And the question is, are there mythologies around stars from like Eastern mythology?
Absolutely, there are. I will confess right up front, I'm not familiar with any of the details apart from knowing that, yes, there are. For example, like with the McAuliffe-Shepard Discovery Center, we have a portable planetarium, so we can like go to schools and set up in their gymnasium and such. And one of our older portable planetariums had what were called cylinders, and with lines that connect. So that's another thing I could show you. Is like, see, uh, that's the C for stellarium users. You push the C, you get constellation lines. And we had a cylinder that was Chinese. Okay, so Chinese mythology, and then there's African mythology. There's Indian, Native American, United States Native American mythology. So there are definitely other mythologies besides the Greek and the Roman that we're more accustomed to. So the answer is yes, but I don't know a lot about them.
Fascinating. Okay, and here's one more question. So we'll go on to the next thing that you're going to share. But this question is, how many stars are there in the sky? I know you said you could see if you were in the
1,500.
darkest place, you could see 1,500. But I mean, are there more that we just can't see with our eyes?
Oh my goodness, yes.
Yeah.
So just in our galaxy, our Milky Way galaxy, um, which is one of trillions of galaxies, we have a distance across, like a diameter. I used the word light year before, about 100,000 light years across. Our sun in our solar system is about a third of the way in from the edge, about two-thirds of the way left to go to get to the center. Okay, and in our galaxy alone, about 300 billion stars.
Mind blowing.
It's
That's just
huge.
mind blowing. Fascinating. Thank you. All right, let's go on to the next thing you're going to talk about, and we'll take some more questions as you go. We'll
All
save it
right.
till the end.
Okay. So I'm taking the sky for a spin, and I want to. We looked south because the nice thing about the southern sky is you look south, the constellations change more quickly. They go across the sky. That's where you're going to find what's called the ecliptic and the zodiacal constellations and such. But now I'd like to share with you the north, because the nice thing about the north sky is it's always there. It changes in terms of its perspective, kind of rotates, but the constellations and the shapes and the stars, they're always there in the north sky. So now again, this is the sky from Concord, and now we're at 9 o'clock at night. And I'm not going to reset the time. 9 o'clock is fine, I think. So you see the big red N in the sky, and that's because we are facing north. So the most prominent item in the north sky, I'm going to, let's see, yeah, pull back just a little bit to make things just a little bigger here, uh, is the Big Dipper. Okay. And so maybe you can see off to the side here, off to the right, the Big Dipper. And the Big Dipper is not a constellation. So many people think the Big Dipper is a constellation. It's, maybe the first constellation that anybody, kids learn, but it's not a constellation. It's what's called an asterism. An asterism is a familiar shape made up of stars that may or may not be from the same constellation. So in this case, and I'm going to, like we were talking about cultures, I got a couple things to say about the Big Dipper. But the Big Dipper is part of, let me put up the lines first. You see that there's a lot more to the Big Dipper. You've got coming up here, here, down here. It's the Big Bear. It's part of Ursa Major, the Big Bear. And so the handle of the Big Dipper represents a very elongated bear's tail. Then you have the bear's back. These stars make up the head. You have stars, including the stars at the bottom of the dipper making up the belly of the bear. Then you have front legs and you've got back legs coming around. And this is, I would say, to answer, address William's earlier or first question, this may be one of the constellations that maybe you can see a bear, if you look carefully. So the Big Dipper, a couple of things about the Big Dipper that come in handy. One is, I'm going to take the lines away, but if you look at the handle, again, binoculars will help, but this is something you don't need binoculars for. If you look at the middle star of the handle of the Big Dipper, the two stars' names are sorry, I take that all back, Mizar and Alcor, Mizar, Mizar, and Alcor, Alcor, not to be confused with Al Gore. Okay, Mizar and Alcor. Mizar is the brighter one. When you look at the Big Dipper, you say, okay, 7 stars, there they are. And this is one thing I got to tell my astronomy students and everybody, take time to observe. Again, we're so used to the going out and standing on our back porch or in the driveway and looking up for 5 minutes and say, okay, I'm done. It's cold. It's winter. It's New Hampshire. Dress warm so you can enjoy it. I always keep a summer lawn chair handy on my porch because I go out in the winter and I sit down in my lawn chair and I'm dressed warm, long johns and parka, hat, gloves. If I'm going to go out and watch a meteor shower, a blanket, a sleeping bag to wrap around me so I can be warm. Hot chocolate, donuts. And it's just so great to look at the sky because the longer you wait, after a half an hour, you're even going to see more stars because your rods and your cones get more adapted to the dark and you see more. So what am I saying about Mizar and Alcor? Take some time and look at that middle star of the Big Dipper. There's 2 stars, not just one. There's 2 stars there. There's a faint companion that you will be able to see. Native Americans, legend has it, used it as an eye test. If you can see 2 stars, you've got good eyesight. And I think that'll just be fun. The other thing about the Big Dipper is the 2 end stars. Well, actually, there's another. Oh, there's so many things about the Big Dipper. The end star's name is Alkaid, Alkaid, and Alkaid is the century star, and I call it the century star because it's 100 light years away. So if you know of any 100-year anniversaries coming up, like, if you look in the history book or on your calendar, what or who is having, and obviously there are people alive that are, having their 100th birthday, and you look at Alkaid. So let's just say, just for example, okay, just for fun, if I had a grandmother that was alive, and unfortunately I don't, but if I had a grandmother who was turning 100, I could go outside and say, "Hey, Grandma, come on outside and look at this star. See that star at the end of the handle of the Big Dipper? The light that you're seeing from that star right now is the photons that left that star on the day you were born." Isn't that cool? It's the century star. Okay. Um, the other thing is these two end stars of the Big Dipper, Merak and Dubhe, or some pronounce it Dubhe, Dubhe, and Merak, Merek, Merak and Dubhe. And notice that so many of the stars have Arabic names because they were the first ones, again, going back to Mesopotamia, Babylon, Baghdad. They were like the first ones to care and looked at the sky and the stars and named things. And sometimes if you're the first to name them, the names stick. So many of the brighter stars have Arabic names. So if you take Merak and Dubhe and you make a fairly straight line, it brings you to Polaris, which is the North Star. Polaris, the pole star, the North Star. It's almost directly over the rotational axis of Earth. Excuse me, not exactly. It's about 3/4 of a degree off dead center, but it's pretty close. And I'm going to show you something about that in a minute. And you see how the Little Dipper pours back into the Big Dipper, which is kind of cool. So you take the two end stars of the Big Dipper, Merak and Dubhe, they point to the North Star. The North Star points back or pours back into the Big Dipper. And I wanted to point out this star right here. I don't remember its name. It's a magnitude 5 star. Polaris itself is a magnitude 2 star. So it's 2.5 times dimmer than Aldebaran. It's 6.25 times dimmer than Betelgeuse or Rigel or Capella. So the North Star is not the brightest star in the sky. It's actually about number 48 or 49 on the brightness scale, number 48 or 49. And there are 7 stars in the Little Dipper, which represents the Little Bear. Okay. But the star that I'm pointing at here is the faintest star in the Little Dipper, and it's a magnitude 5. So if you go out Wednesday night and it's clear and dark, take some time, see if you can find all the stars, all 7 stars in the Little Dipper, and see if you can see this one here. If you can see all 7 stars, it's what we call a good night for seeing. Magnitude 5, it's pretty decent. If you can see a magnitude 5 star, it's a good night. And I challenge you to find a magnitude 6 star. The last thing that I intentionally want to show you, and then we'll pause for questions, is if you take the middle star, Mizar and Alcor, right, of the Big Dipper, and you go through Polaris, which is the North Star, and you keep on going, you come to this W shape, or this time of year and night, it looks like an M. Depending on the night, the time of year, it could be an M, a W, a 3, an E, a Greek letter sigma, capital sigma. But this M shape is Cassiopeia, the queen. And so I guess while I'm talking about the queen, right next door, this envelope shape or this house shape, that's the king, Cepheus. So you have Queen Cassiopeia on her throne, enjoying her beauty, and the king, Cepheus, represented by the house, right? A man's, how does it go? House is his castle, something like that. Okay, so let me take the lines away and we'll just see. Let me see if I can see what the name of that star is. It's a double star. See, it's a magnitude 5, 4.95. Anwar Farkadin. Yeah, I'm not going to remember that. Anwar Farkadin is the name of the star. And I guarantee you I'm not going to remember that. Okay, so that's what I wanted to show you in the North sky. One more quick thing. As I mentioned, the star Polaris, the North Star, is over the rotational axis of Earth. So what I'm going to do now is I'm going to take away the atmosphere, which is A on the keyboard, and notice more stars came out because I got rid of the atmosphere. You know, the haziness is gone. But what I want to show you is the sun is going to rise, but it's not going to blank things out because I turned off the blue sky, the atmosphere. But watch what happens. When I start things rotating, you're going to see all the stars and the constellations are going to rotate around. So I'm going to put the constellation lines on just to help the illustration. They're going to go around the North Star. So watch this. Earth rotates, and this is what happens as we look at the sky. You can see it moving now, right? Now it's going faster. Okay, this is obviously increased speed, but you see what's happening? See, the North Star is staying there. The Big Bear is going up. The King and the Queen are coming down. The little bear is being thrown around by the end of his tail. Everything is rotating around Polaris, which is over the rotational axis of Earth. Okay, so that's what I had up my sleeve to show you, and I'll take questions.
Wow, that was great. Thank you so much. We have a really big question. It's from William. This is another good winner, William. He would like to know how old the universe is.
13.8 billion years.
Wow, you get that right on the tip of your tongue.
That's well, two reasons for that. One, that is a very confirmed number. Uh, it's that number has been come up with in the past 5 years and massaged from 13.75 to 13.8 billion. And another reason why it's on the tip of my tongue is I'm teaching an astronomy class at Belmont High School right now, and we talked about that very thing today, the age of the universe,
Wow, this is
talking
really
about
great.
cosmology, the beginnings and the end of our universe. So that's the astrophysical number, 13.8 billion years.
Love it. All right. And here's a question from the last night sky you showed us, and I didn't see it, but I want to ask it. The color of Sirius, the star, or Sirius, is it a blue-green? That's what it appears to be, according to the person who wrote the question.
All right, let me show you using the technology built into Stellarium here. So if I click on the star, it shows up over here, and so it shows the color index here, and the color index is B. So B star is a blue star.
Great. All right. And here's a question that
Bluish white, bluish white.
Bluish.
The O are the blue, and then a little bit to the left of that is what I mentioned, the electric blue, which is kind of a new thing. But O are blue, and the B, which is what Sirius is a bluish white.
Great. And this will be the last question for tonight because I see that it's already 8:05. But it is a question that I'm sure lots of people have wondered about. It's from Stephen. He wants to say, light from planet is steady, but light from star twinkles. Why is that? Why do stars seem to twinkle and planets don't?
Excellent question. Remember, we have an atmosphere, and I'll turn the atmosphere back on, and you can see a little bit of haze and such. And you can set Stellarium up to twinkle. I'm not sure if these stars are twinkle. I don't know that I turned the twinkle feature on. But anyway, the answer to the question is this. Our atmosphere is made up of a lot of water. There's a lot of moisture, a lot of H2O in our atmosphere. And it refracts, it burbles. Stars are pinpoints of light. Even when you look through binoculars, they're just pinpoints of light. Even when you look through a telescope, stars are pinpoints of light. They don't have any dimension to them. They're just pinpoints. And so the atmosphere scintillates those pinpoints. They get a little brighter, a little dimmer. They look like maybe they wobble a little bit because they're just pinpoints at the mercy of our atmosphere. Planets actually have a size to them. They actually have a disk that is measurable. So, like Jupiter and Saturn, those are disks that you can see, and through a telescope you can see it's a round circle. When you look at Mars that I showed you, which is right over here, when you look at Mars through a telescope, you'll see it's a disk. There's a little circle there. It's not a pinpoint. Uranus will be a pinpoint because even though it's a planet, it's so far away. So Uranus would twinkle if you could even see it. But Mars is a disk that you can actually look at. So
Great.
that's that answer.
Yeah, thank you. Dave, thank you so much. I feel like you just gave us the gold, so much information packed into this hour. It's really impressive. And if you can send me the link to your TV show and radio shows, I think that lots of people will be tuning in because this was really fabulous. If you were at the Harris Center and we were all there with you, I know you'd get a standing ovation. That was really great. I'm going to give you a hands like, yay. And I want to thank everybody who showed up tonight for Dave's talk. And yeah, Dave, send me the stuff and we'll send it out to everybody. And thank you all for coming, and have a fabulous weekend, and get outside and stargaze. So.